All right, now that we've talked about some important things that we're going to carry throughout the rest of the semester as far as measurement goes, thinking about those sig figs and thinking about those units, let's get into the heart of some chemistry. So let's learn about matter. We're going to start by talking about the states of matter. This should be a review for you, what the states of matter are, but maybe we'll be delving a little bit more into detail about what is different and what is the same between those states of matter. Okay? All right, let's talk about the kinetic molecular theory, or KMT theory. You should have learned about this in physical science. So everything is constantly in motion. So the particles that make up matter, atoms, they're constantly in motion. They're always moving, even if we can't see them, right? Because they're so small. So if you're sitting at a table or you're sitting in a chair, it doesn't feel like it's moving, right? It feels like a solid object, but it's actually made up of trillions of different atoms, and those atoms are constantly moving. But because of the forces between them, it makes it feel like it's solid, and to us it feels like we're not moving. The kinetic energy of these particles that make up these objects increases as temperature increases, okay? So kinetic energy is basically the speed at which something is moving. So if it's moving faster, it has more kinetic energy. If it's moving slower, it has slower kinetic energy. Okay? Temperature is also a type of energy. And so these two correlate together. As temperature increases, it increases the speed of those particles. As temperature decreases, it will decrease the speed of those particles. Okay? So let's talk about the four states of matter. Of course, our first one, we have solids. Solids have very low kinetic energy because their molecules aren't moving very far or very fast. They kind of just vibrate in space. Okay, so we know solids, they have a fixed shape and they have a fixed volume. Okay, so they don't change. So your cell phone is a solid. When you pick it up, its shape doesn't change, right? It stays like it is. If we compare that, let's increase the kinetic energy, okay? And let's stick with something that we all know a lot about that changes, and let's talk about water, okay? So water, when it is ice, it's very cold, it has very low kinetic energy. The water molecules in ice sort of vibrate in place instead of moving. And so while it is solid ice, it has a specific shape. So you can have ice cubes, right? So they have that specific shape and volume. But let's increase the kinetic energy. Let's warm up that ice cube. What happens? Those water molecules begin to have more movement. Okay, they are now able to slide past one another and slide around. They still stick pretty close together, but they do have more freedom of movement. So now we have a liquid. Okay, now liquids, they still have the same volume. They don't change volume, but they can change shape, right? Liquid water takes on the shape of its container. So if you pour it into a round container, it becomes round. If you pour it into a square container, it becomes square. Okay, so now we can change the shape, but it still stays the same volume. Let's add more kinetic energy. Let's heat up this water some more. Okay, when you do that, it can turn into a gas. Okay, gas has high kinetic energy. Now the particles can separate and they can move around. So gases now have variable shape, just like a liquid, but they also have variable volume. They take on the volume of their container. That's why when you're boiling water on the stove, you see that steam rising. That steam is those water particles turning into a gas, and they are spreading out in your kitchen, taking up all that space. There is another state of matter that has even higher kinetic energy. So increase the kinetic energy even more to the very highest level, and we get what's called plasma. Plasma is gas-like in that it changes its shape and its volume. It can expand to fill its space. But the difference between a gas and plasma is that the particles in plasma have such high energy and such high speed that if they collide, they can actually break apart into charged particles, positive and negative particles. Okay, where can we find plasma? We find these in stars and in the fluorescent light bulbs. Okay, and then CRTs, those are like the little tubes that were in the super, super old big box style TVs. Okay, that's where you can find some plasma. Very, very high energy. Such high energy that the particles colliding actually break. Okay, now let's talk about classifying matter. Okay, this is a goal for you today. I want to be able to give you lots of examples and you be able to classify what category they belong in. Okay, so I'm going to start by giving you a flow chart. I highly suggest you pause here and copy this into your notebook so that you can use it to work through. Okay, so you can ask yourself a question. So everything is matter, right? So when we look at a sample, we have to ask ourselves, can it be physically separated? If we can separate it, we go to the left side. Yes, it can. If it cannot be separated by physical means, then we say no and we go to the right side. Okay? And then we can further go down there by asking those questions in the right. Okay? So let's go through. This is a lot of vocabulary for today. So let's go through these vocabulary terms, make sure we understand what they are, and get some examples. Okay, so here are some of those vocabulary words and some examples for you. So graphite, that's what's in pencils. That is an element. Graphite is just carbon. Okay, pepper, like pepper that you put on your sandwiches or on salads in your kitchen, that is a heterogeneous mixture. So when you look at it, it doesn't look all the same. It looks like a mixture. There's little black flakes, little white flakes. Sometimes there's little red or yellow flakes depending on what type of pepper you have. So you can see the differences throughout. That's that hetero, differences. Sugar, like table sugar that you sweeten your tea or your coffee with, that is sucrose. That is a compound. Paint is a heterogeneous mixture. And soda is an example of a solution. So let's go through all those vocabulary terms together. Okay, so let's start with an element. Okay, so an element is a pure substance. You cannot easily and physically separate it. Okay, so an element is something that is composed of all identical atoms. So these are all the things found on your periodic table. So anything on the periodic table is going to be an element. So you've got copper, aluminum, hydrogen, oxygen, okay, all of the same element. It is pure. Another pure substance is known as a compound. So a compound is when you take two or more elements and you chemically bond them together in a fixed ratio. Okay, so the elements always have a fixed ratio. If you change that ratio, it's not the same compound, right? Okay. And another important thing to note about a compound is that the properties of the compound are different than the two individual elements that make up that compound. Okay, for example, table salt. Table salt is made out of one atom of sodium and one atom of chlorine. Okay, chlorine by itself is a poisonous gas. Okay, sodium by itself is a highly explosive solid. Put them together and they become a delicious, safe table topping. Okay. Something to note with pure substances are these two laws. The law of definite composition. So a given compound always contains the same fixed ratio of elements. So table salt is always one sodium, one chlorine. Okay? And you also have the law of multiple proportions. Elements can combine in different ratios to form different compounds. So if it's not one sodium and one chlorine, it's a different compound, but it can still exist. Okay, so for example, carbon and oxygen. If it's one carbon and one oxygen, it's carbon monoxide. If it's one carbon and two oxygens, that's a different compound, but it is still a compound, but now it's carbon dioxide, and it has different properties. Okay. Next, let's talk about mixtures. This is a variable combination of two or more pure substances. Mixtures can be separated by physical means. You can separate them out. Okay, so with mixtures, there's two categories. You can have heterogeneous mixtures, okay, where you can, like this stone here, you can see the differences, the different pieces. Or you can have homogeneous. This is where you can't physically see the difference because it's so well mixed that it looks similar all throughout, like this apple juice. Okay. So within mixtures, we have solutions. Solutions are homogeneous. They have teeny tiny little particles. They're so small that they never settle. So a soda. If you leave a soda sitting in your fridge for a week or 2 weeks and you go back and look at it, it still looks like a normal soda because nothing settles to the bottom. Okay, another example, rubbing alcohol. Nothing ever settles out. A colloid is heterogeneous because it has bigger particles. They're medium sized. The particles never settle though, but you can't see through it. It still looks all the same, but they're medium sized particles like milk or paint. You have a suspension. This is heterogeneous. This is large particles. Now, how you can tell this one? Particles settle out. So if you leave it sitting for a week or 2 weeks, you're going to start to see layers like fresh squeezed lemonade or soup. You know, a nice chunky meat soup or stew where the meat and the veggies can fall out to the bottom and you got to stir it to mix it back up. Okay, here's some other examples for you. Mayonnaise is a colloid, those medium-sized particles. Muddy water, suspension. Leave it sitting long enough, the mud sinks to the bottom. Fog is a gas example of a colloid, all those fog particles floating in the air. Salt water is a solution because it gets dissolved. The salt gets dissolved in the water. Italian salad dressing, suspension. You got to shake it before you use it because everything sinks to the bottom.